So yeah, welcome everybody to the next in the SCLF Webinar series. Today's presentation is on the CReDiT carbon reduction tools, support sustainable remediation and earthworks on brownfield sites. The CReDiT tool was developed as a joint venture between the University of Surrey and Leap Environmental. So brownfield remediation, typical remediation involves earthworks movements and also uses resources such as clean topsoil that is brought in as part of the remediation process. So obviously that type of remediation is not optimal in terms of achieving sustainability targets, and traditionally cost and time have been more important in the decision-making process than necessarily the carbon footprint. So this tool is a carbon tool which helps designers to evaluate the likely carbon dioxide emissions from different site remediation options and therefore factor that into the decision-making process. The presentation that you're going to see today is going to detail the model and also its application through some case studies. Our presenter today is Emma Hillowell of Leap Environmental. She's a chartered civil engineer and a research fellow at the University of Surrey, and principal geoenvironmental engineer at Leap Environmental, and she has experience working in local government, civil engineering consultancy and academia. So I will pass over to Emma to do her presentation, but just we'll take questions at the end. So as we're going along, if you've got any questions for Emma, there's a questions function box on your toolbar. So if you've got any questions for Emma as we're going along, if you just want to type your question in there, rather than don't use the chat function, pop it into the questions bit. And I will read out your questions to Emma at the end. So I will hand over to Emma, but she has got a poll for you all that we're going to run at the start of the presentation. So I will put this poll out to everybody if you can take part in this, and then Emma's going to get the results at the end. So let me just run this just now. So the poll question is embodied carbon and its reduction included as a factor in your remediation? If everybody could pop their responses in now, and then we'll get the results of that at the end. I'll just wait till everyone's put their answer in. See how many have responded. Okay. Right, that's the poll done. Emma, I'll give you the results at the end and I'll hand over to you now.
Okay, right, hello everybody. Let me just move my screens around so I can see what I'm doing. So my name's Emma Hillowell, as she said, and I'm working for Leap Environmental. And I'm just going to basically, first of all, thank you for inviting me. It's great to get the opportunity to sort of tell people about the work that we're doing. And what I'm going to do today is talk about the carbon reduction tools that we've developed. As we said, this started actually at the University of Surrey. I used to be there, and now I'm at Leap doing the same sort of thing. And I'm just going to show you some of the tool we've developed, particularly the one for remediation, and some of the applications of it. I'm going to slightly apologise because I think the screens are a bit odd, and you might see the side of my head as I'm looking at the other one. So the title of the thing of my talk is about CReDiT. CReDiT is my acronym for my tool. And it's a carbon reduction tool for remediation. So just a little bit of background just to say why we're doing it. I think the fact that you've actually logged into this webinar shows that you've got an interest in carbon reduction. And I guess this graph is showing global carbon emissions, which have been steadily rising despite for the last, I don't know, 130 years or what have you, or even in the last 30 years, even though we've known about climate change, we keep trying to do something about it and we come up with these targets, but we're not really getting any reductions yet. You can see what we need to do if we're going to try and reach our carbon reduction target of net zero by 2050. With current government things, I'm not sure how we're going to get there, but anyway, this shows you the steep curve we've got to go through. If you talk about why is it zero carbon, what we're doing, the big area, I'm in construction. I'm in the business of developing particularly housing developments. And as you can see from this graph, we can show that construction is the single biggest consumer of resources in the UK, with the largest accompanying waste stream, which means it's making a big contribution to carbon. So 38% is from building and construction. Yes, a large part of that is actually what happens in actually running the buildings, but actually it's the materials to start with. And then of course, the other factor we've also got is industry and infrastructure. So these are all, we're a big factor in carbon. It isn't just transport and fuel that you think about. So this graph is a picture of what we could do about it in terms of building a project. And how we can actually reduce the carbon in our projects. Obviously, the top one shows 100% means stop building. Now, I'd quite like to keep my job. And actually, we do realise we do actually need a lot of houses and stuff going on in this country. So what we need to do is really work on this sort of section of the graph. We need to think about how can we do things better? How do we build cleverly, more efficiently? What can we do to improve how we actually construct things? And that's essentially where I'm sort of saying where we're coming in from this. I said we've said working with the University of Surrey. I was an academic at the University of Surrey, and we started with a very small project actually, which was the CReDiT Foundation, which was a quick project just comparing which was better, piled or stripped foundations in terms of carbon. That little project seemed to just grow massively, and then I got funding for a project to look at remediation, which is actually more my background. I actually done brownfield development is my area of interest. And so we had developed CReDiT remediation project. Since then, that funding ended, or what? I sort of ended up, no more funding for that kind of work going on. So I got a job with LEAP to do it the other way around. And therefore, I'm now developing these tools within LEAP rather than as academic. Oh, I've gone too far, but just today I'm just going to predominantly focus on CReDiT remediation because that's the field that you're generally interested in, but they all overlap anyway. Just to give you a bit of background about the tool, I'm going to go explain what it does or where it's come from. And I don't know how much everyone knows about carbon and how you develop it, but actually to work out embedded carbon is a really quite straightforward calculation. It is literally mass of material against the carbon factor. So if I want to know the embodied carbon in putting material in a landfill, I need to know the mass of material times the carbon factor for landfill. Very straightforward. Some of these are really, we can get these numbers out of databases. There's a government database that produces a lot of this. There's also RAP have got some databases. So there's a lot of these numbers are sort of out there in tables that I can pick the numbers from. But for what I want to do, some of them aren't. And therefore you have to think about, okay, there isn't a carbon factor for, if I want to excavate contaminated soil, what am I going to do? So you have to think about, okay, how am I going to develop a carbon factor? And that is that literally, well, the carbon that's going to be released is from the diesel use of the equipment. And then therefore you come back to, okay, excavators, how much fuel do they use? How long do they take? And then you come down to how big's the bucket and what kind of soil it is, because obviously some are easier to dig than others. So we come up with carbon factors for activities. And I think that also brings you into aware of carbon factors aren't perfect. They're an estimate. And I think that's something I want to get across in this whole thing is I can't give you an exact number of embodied carbon directly, but I can give you an estimate. My best, not guess, we've gone further than that, but it is the best I can come up with at the moment with the data. So you sit back and think about remediation. This is how I actually started the whole thing. You sit and go, right, brownfield remediation. I did the most common remediation we use in this country, which, because I'm generally what I've been aware of on residential sites I've been involved in, we excavate and we cover. And therefore I've applied it initially just to that. And therefore you have to think, okay, what are all the processes in that when we do a remediation like that? So this is a nice, simple schematic. It's just showing you, we excavate the soil, we put it in a pile. we screen it. We take all the different fractions. We might be able to reuse some of it on site, or it has to go off site. Maybe we can process some of it, or it goes in the landfill. And it's literally looking at what are all the processes and where's the fuel being used or where's material being used. So if you take that schematic and turn it into a calculation. The calculation is a similar kind of thing. It's, as I said, the top line, excavate my material times a carbon factor for excavating. If I want to reuse it on site, how much material am I going to reuse on site times carbon factor for moving the material, for screening the material and spreading it. There probably are a few more moves in there because we tend to move material around site. But anyway, it gives you an idea of what it is. So I started off thinking this was quite straightforward. This is, yeah, oh, it's a spreadsheet. You just do that times that, add them all up. And then you realize, oh, hang on a minute. When I'm on a, I've worked on a remediation site, we have to start thinking about the material. And it's not quite as straightforward as that, is it? Because we excavate material and then we split it. Topsoil, made ground, natural. And we do different things with the different materials. And this one also shows you the made ground, that we split that into all sorts of fractions we might have. And therefore, actually what happens to each of those, oh, sorry, I've gone too far. There you are. This shows you potential material stream of what happens to things. Basically, yes, some of it we try and reuse it on site. And if we don't reuse it on site, can we reuse it off site? Or is it processed? You'll see on the right-hand side, some of the materials are metal and wood. We might be able to process them, or do they just go straight to landfill? So I suddenly had to think about carbon factors, material streams, and bring it all together. And that's what, oh, golly, I keep clicking the wrong button, sorry. Oh, it won't do the one in the middle. There we go, eventually. Right, so actually, what CReDiT really does is effectively it takes in what we get from site data. The site, I get it from GIS of our geology, our contamination, and we have perhaps a potential remediation design that someone's come up with, and that is combined with these material streams, carbon factors and volumes. What I get out of this is I get my equivalent carbon calculation, which is great. That's what we were aiming for. But what I didn't realize is we also get other stuff. We also get the carbon contribution of the different streams. I get a lot of volumes, which is actually really useful. What are the waste volumes and what are they? So that just came out as a byproduct of actually the software, but it's actually proved very useful. So that's the background to it all. That's what CReDiT remediation sort of is. I thought the best way to do it is to show you. Now, I'm sorry, my mouse is being funny, as you can see with the, hang on, I'm having a problem with let's just hit that. Right, if we go to the first case study I'm going to show you is a landfill. And apologies, I have shown this one before because it was actually where we started. So we had a development site and it was basically, it's going to be residential houses with gardens. What it previously was a brickworks, and of course brickworks, holes in the ground, we tend to infill them. So there was an early infill from the 1900s, the north of the site that was full of lovely bottles and sort of more Edwardian infill, and then commercial landfill in the 50s, and then it was capped. So we did the site investigation, and this is our sort of schematic of what you get. You can see there's quite a lot of made ground on this site. This contour on the left shows you the thickness, and it was up to 9 meters thick in places. The contamination, heavy metals, PAHs, a little bit of asbestos, and just some residual methane, not too much still on the site. So for the remediation, I'm just going to give you a demonstration of just how the model could be used. This is a bit simplistic to start with, but it shows you the progress. So if you take that site, what we could do is we could just put 1 meter of cover on it. That's case option 1. Option 2 is to excavate and remove about 1/2 meter and put 1 meter of cover on. And option 3 is take away 1 meter and cover it with 1 meter. So they're the three that I just plugged in as a sort of starting point. And if you see the results on this, you end up with options 1, 2, and 3, and this shows you the tons of equivalent carbon. And you can see for this, they've all got 1 metre of cover, so the green block is the same in all of them. That's the carbon contribution of importing cover material. And obviously the options 2 and 3 involve excavation and landfilling material. And I mean, this is actually showing you probably the absolute obvious, that if you're going to excavate more and excavate more, it's going to cost you more in carbon. So it's just showing the basics of how it works. What the CReDiT sort of did when we first ran this was we also got information on the material. So if you think about this landfill, it was quite an interesting one. It's probably because I went there and saw the stuff that I actually added a few more material streams, such as glass, metal, paper and wood. They're all in there. And you can see the biggest volume for this site was hazardous waste. And if you look on the right, it shows you the embodied carbon if you landfill this material. So funnily enough, the hazardous waste is the biggest volume, and that's the biggest contribution potentially to carbon. However, on the other one to look at here really was the interesting one, wood. There wasn't that much wood on the site, but it makes a big contribution because basically wood's obviously going to give off more CO2. And then we sort of note slightly other things. You sort of look at the metal. It's quite an interesting thing. Is this, perhaps we could do something with that. So we sort of use this just to have a rethink about what's happening on the site. So if you do the next stage, you go, okay, so we had our first basic remediation idea. Now let's try refine it. So let's do, what's the maximum reusable material that we can use on site from the topsoil or screen material? Can we reuse any of this material off site? It wasn't that good for this site actually, so I haven't really included that. But the other thing you really do see is there is potential to think about the processing of the wood, the metal, and the glass. Maybe we introduce that into our carbon model and have a think about what that's doing. So I've rerun the same assessment and include all this, and you get a different result. So this graph is exactly the same. So number 1, 2, and 3 are just what I showed you before, the blocks going upwards. 2B and 3B are when we include reuse of material and processing. And you can see immediately you get a massive saving in carbon just by, the big difference really here is you have to say if you can reuse material on site, you reduce the amount you need in cover, so the green, it gets smaller, and therefore you're also reducing the amount that's going to landfill. So there's sort of a double gain here. The other thing to note, this is a bit hard, this was really tough for me to actually absorb at the time, is I suddenly get carbon saving, which is because metal is so valuable in terms of it's got such a huge carbon footprint. By recycling it and reusing it, we start to gain carbon back. And so suddenly we end up with it was very odd to put in carbon factors with negative numbers rather than positive. And this is what it tells you in terms of, this is just pure what the data's telling you. If we move on again, I should say that was a very simplistic view. When we actually run it properly, it looks more like this. We zoned our site. We thought about it in different landfill areas. And the schematic at the bottom shows you what CReDiT looks like a bit, where we can look at the topsoil and made ground in different areas of the site. And we can apply different remediation ideas to different parts. So we sort of, in the end, reran it. And these are just, you can play with it. I actually can run about 6 different ideas at the same time and just see what it's telling you. And option 5 here was a pretty good answer at the moment, which was to, okay, just put 0.6 meters of excavation and 0.6 meters of cover in zone 1 and leave the other area at 1 meter. And that was a suggestion of this one actually is quite an efficient way of doing the site. I should point out actually at this stage, we're not charging for this kind of work. We're doing this in our phase 2 assessments, because we just think it's a good idea for people to think a bit more. So when we put forward an idea of suggestion of remediation, we're sort of just saying, you could do this, but this would be better, and just give them a bit of an analysis. So that's sort of the first case study, and that's how we started with the project. We then, it's funny how different things come in and you start using the same tools but in different ways. So the second case study I'm going to show you is an airfield. I'll just give you the background. It's 115 hectare site, and it's a massive residential areas proposed with lots of natural green space. Being an airfield, it was contaminated with fuel and some asbestos fibres. And in this case, we weren't actually looking at what's the best remediation technique, because they'd actually wanted us to run it with, this is what we're proposing at the moment. So the remediation they're talking about was 600 millimetres of excavate and clean cover in the garden areas and 300 millimetres in the open space. So we were running with that. What they wanted to know, if I put this up, was they really wanted to know what are the carbon savings we can get from doing material reuse? And they wanted sort of just numbers on this to work out, is this a good idea? How much of a good idea is it in terms of just carbon? So I ran this for the airfield, and the first thing I'm going to show you is about the soil. And again, I'll do this in options. First option is what I call the base option, which is your worst case scenario, which is what would happen what's the carbon use if everything you excavate goes to landfill and all the cover you require is coming from a primary source. I'm not saying people are going to do that, but that's your worst case scenario. The second one is to try and just reuse material on site in the cover and the excess goes to landfill. And the third option is if we reuse everything on site, what we're going to save in carbon. And I've just put on this one, by this time we'd actually decided to also include in CReDiT different HVO fuel as an option for site plant. I'm not using it for transport of material, but I'm just using it for just the excavators and any site plant. What are the carbon savings in using HVO fuel instead of diesel? So we were running our scenario just for this is just the soil bit, the same sort of blocky plant results. I'm going to show you this one is showing you the tons of carbon relating to the base option. So I showed you our worst case option is diesel and everything goes off site or is brand new, and that's R1 as our 100%. You can see immediately if we change to HVO fuel for site work, we're saving about 12% of the carbon already. Obviously, the really big saving here is let's try not bring in any cover and reuse everything on site. And not only you can see this makes a massive difference by I don't have the big green block because I'm not importing anything, but it also massively changes the amount going to landfill because I'm reusing as much as I can on site. So suddenly option 2 is massively better than our worst case scenario, even with diesel. And our third case option where we're using everything on site, if you use it with HVO fuel, that's mainly the only thing that's taking the carbon because it's nothing to do with materials. It's just the plant operating on site is producing carbon. So you get huge savings. I mean, we're down to just compared to the worst case, it's just a massive change in where you're thinking. So that was for just the soil. If I actually show you the site, this is the runway, 2 kilometres of runway. And next to it was a big area where they used to have hangars. And the one thing, first thing really obvious to anyone on that site is there's a hell of a lot of concrete here. So our first analysis was run with the soil because that's what CReDiT did. We did soil. And so I then had to modify it to then go, okay, concrete. Let's include concrete breaking out, crushing in our analysis and rerun it. So I reran the CReDiT model just for the concrete on this site. And again, I'm going to show you this with 4 options. C1, the worst case, all the concrete goes off to landfill. Second option, all the concrete is reused elsewhere. The third option is we're going to reuse all that concrete somewhere on site. And the fourth option we brought in was, yeah, some of the concrete, not the runway, but the hangar area, all was reinforced. And therefore, there's a lot of steel there. So what would happen if we could get that steel out and process it? What does that do to the carbon? So if I rerun all those options, and plonk it into my carbon model, I get my worst case scenario of let's stick everything in a landfill. You also notice on this one that the excavation was actually always quite a small fraction, but when you're including breaking out and concrete, it's getting a bit bigger. So you can see worst case scenario of C1, send everything off site, reuse it on site, we're reducing it. C3, when we're reusing it all on site, we're saving a lot of concrete. C4 is the weird one. When we start, if we can get the steel out of this stuff and reprocess it, we end up with a negative number. So there's this idea of, oh, so if we can get the steel out, are we talking about carbon neutral or better for our process? I have to be slightly skeptical about this, and I'm slightly worried. I put this graph up and I'm always a bit worried that I'm slightly greenwashing what we're doing. It's a bit too good to be true. And I also know that the carbon factors you get for some things, like this, the carbon factor for glass, for example, there's a carbon factor if you reprocess lovely glass that's all the same kind. And then there's the carbon factor for reprocessing stuff perhaps that we might have got out of the landfill. And that glass can't be reused. That's not going to be reused to make bottles. That's going to be reused for aggregate. So you have to make sure you've got the right carbon factor. So I'm still slightly skeptical about the steel, the recycling of the metal. But I think the main point to show on this is it's a valuable resource. We ought to think about using it, and it might help with our carbon for the process. I'm not totally sure it's going to make it neutral. But, so that's that site. Oh, I should just actually, summarize all the savings. Yeah, be careful. Ideally, we would save 20,000 tonnes in carbon by reusing everything on site of the soil. But you have to realize what goes with that. I think the main thing is it's not just carbon. I mean, the whole sustainability comes in here. If you don't remove, transport, or dispose of 400,000 meters cubed of waste, I mean, you're doing, apart from the local community in Surrey, they'd probably quite be happy that all this stuff's not being transported around past them. So it's a massive saving in that scheme as well. I've put this thing, could including concrete and steel make that bit okay? Yeah, okay, it's something to include. And when we do the numbers, we end up with a total carbon saving of 26,700 tonnes compared to the worst case scenario. You have to be careful with these numbers, as I say, but anyways, you can make big changes. All right, so the final case study is about using it for MMP type work. So we're given the client with sites all across Kent, and you can see these are sorted out into topsoil and subsoil, donors or receiver sites. And they gave us this map and they gave us distances. But most importantly, really for us, I got a spreadsheet of the amount of material. So I got a spreadsheet of the site, one material at the site, and how much material was required at a site. And therefore, this becomes a sort of soil balance type equation where we can reusing material or transporting it locally. So we can put that information in as well, and we can have a think about how it's saving. You sort of get used to I'm afraid this is how we all do it with my options. Option 1, worst case scenario, which will be on all our sites, all the excavated material goes to landfill and all the covers coming from elsewhere. That's our horrible baseline. Option 2 is where we reuse the material we require on the site. The excess goes to landfill, but if we do need any cover, we're going to bring it in from elsewhere. Option 3 is what the client is really doing. They wanted to show how much they're saving by what they're doing, which is to reuse material on site, or if we can't reuse it there, we'll find another site to use it. And therefore, only the excess is going to landfill, and we don't need to bring in any cover. I mean, this all comes out because the mass balance tends to work that we excavate more than we need to bring in, or we did with this data. We put a couple of extra options in, which was to try reuse all the material. So let's not, if there's any excess, we can reuse it somewhere else, or try use all your material on your site and just run it and see what the data says. The key thing here is you've actually got this big area. By saving landfill and saving cover import, you're probably making a big impact. And that's what the results show. So if I show the results, this is option 1, our worst case 100% scenario. What kind of savings can we make? And as I said, option 3 is the one where that's what the client's trying to do at the moment, and they're doing quite, it's really good. They're saving 28% of carbon by doing that. I think what we wanted to focus on was, yeah, but you could do even more if you thought about reusing more material. You can see that these big blue bands here, this is the landfill excavated material. We need to get that down. We need to reuse that somewhere. It could option 4 was reusing it somewhere else, and 5 was trying to use all of it on site. Now there might be a happy medium in this, but it makes you think about, hang on a minute, we can make some big savings here. What we also did was actually divide this up into topsoil and subsoil. These graphs are to the same scale. It's the same data showing the carbon for the different topsoil options and subsoil options. I think we're all pretty aware that topsoil is really valuable, and we can often find reuses for it. We'll find somewhere, not this site, but the next door site. And therefore, the savings there aren't as massive. But if you look at the subsoil, there's some massive savings to be made if we can find more uses for our subsoil. So from option 3 to option 4 is the biggest saving potentially, and it's just trying to find a use for subsoil. So just to sort of summarize those sort of points, what we've got is, you can see that site material management is really almost the key point in all this. It's like, it's not just saving carbon, it isn't about just fuel. We worked out that the fuel bit was the small bit. The big bits are really actually about material. And therefore we need to start thinking about what measure we can use. Produce less material. Can we opt to, how do we need to dig as much as we dig? I say I have another sort of program that we've done, which is CReDiT Foundation, which looks at, well, which is the optimum foundation? Might produce less spoil. Can we reuse most of it, maximum amount we can on site, or find a use for it locally? And bring in this idea of, what do we do with the subsoil? I think there's a lot more ideas we can do with that, perhaps focus on what, just uses for it that save it going to any landfill. So just to sort of bring this, all the sort of conclusions, for the sort of what I've just presented, hopefully I've shown carbon tools are really useful for option appraisals and promoting carbon reduction in remediation design. And it's not just about the design, it's about your material use. I think hopefully I'm showing it's not just carbon. Carbon is one factor, but carbon is really linked to sustainability. And I don't know, the main focus I'm sort of saying is materials waste reduction and material reuse and make the biggest impact in carbon. Yes, we can make impacts with our HVO fuels. They are, it showed that was, but actually rethinking about materials makes an even bigger impact. So where we're going at the moment, I mean, we've got this CReDiT remediation. I keep being asked if I've done it for other remediation types, and it's sort of like, yeah, okay, I ought to expand, and we ought to do some other remediations, not just dig and dump. So yes, we'll do that. I've got also more work to do on the other ones, particularly earthworks, because that one's the trickier one because it's less defined, and we're moving more soil around sites. What actually happens on site is quite hard to really pin down. And ideally, we want to combine them all, so you have some sort of site development package. We're working on putting them online. We're starting with CReDiT Foundation because actually it's the one most used in our company. At the moment, we are using this in Leap Environmental. Well, Leap Environmental was a small consultancy that sort of last year became part of RSK. So at the moment, we're using it in Leap. We're sort of expanding it for RSK to be able to use it. And we're in discussions about what we do. Is it going to be something we let everyone have a play with, or does it? We're not quite sure where we're going with it yet. The other thing I am doing at the moment is actually just, we've got, I can writing tools for particular clients who want. It was a bit like we did the work for the with the concrete at the airfield. That was a particular slightly different package. But we also are doing ones where they just want to assess their site for issues. Can we write something for them? So we're sort of looking into that at the moment. So that's my sort of summary of what we're doing with it. I don't know how, where it fits into all the work that you're doing, and have you got any questions?
Thanks for that, Emma. I've got the results of the poll that you ran at the start. I'm not sure if this is what you're going to be expecting. So the poll results were, so 19% of respondents said yes, we use in-house tools to calculate. 9% said yes, we do calculate using industry available tools. 16% said only when requested in a tender, and 56% said no, but we are looking at introducing it in the future. So I don't know if
it's really interesting. It was trying to work out what's going on out there. This is what we're doing, but I didn't know if other people were doing the same.
Yeah, so I think some are. If you add up the ones that said yes in one function or another, it's about 30%. So yeah, that's actually a bit more than I thought it might be, to be honest with you. So there we go. Yep. We have had some questions, so I will put those to you just now. So the first question that we've had from Helen McMillan is, do you think that by considering carbon within the remedial options appraisal, that some technologies may become obsolete on the basis of sustainability reasons, e.g. move away from dig and dump or high energy thermal treatment to reuse on site? Sorry, it's just cut off the bottom bit of the question. But
yeah, the answer, well, it depends what's driving the remediation, isn't it? There might be something that the high energy ones are the only option left because of what's actually on that site. But I say we haven't done the comparison between them all. So I haven't done the, as you say, do something, a thermal treatment kind of what the carbon is compared to dig and dump. I mean, we always said we were going to move away from dig and dump years ago, and we still haven't, because it's just, I don't know, it's just the reliable one that we know more about. But yeah, I think that's the work to be done, is to actually start doing it for all of them and including it. I think it's just one of our idea is it just should be one of, it's not the only reason for your remediation. Obviously you've got to make sure you're covering the other bases, but it's almost like just thinking a bit deeper and including it in the assessment. Yeah.
Okay, the next question from Sally Shaw. Has this been used for on-site reuse of material that has been laid down as waste, which needs to be treated first to not legally be a waste?
At the moment, the quick answer is no, but you could do that. It's like with all these things, you've actually got to try. So I've got the amount of material, and it's what's the carbon factor for that processing. And that's the bit you've got to try and work out. That's the hardest bit if it hasn't been done. If it does, it depends what it includes. Is it just a fuel use to do something? That's easy. But if it's others are more tricky to find out. But yeah, it should be included if you're going to do that.
Okay, another question from Helen. What feedback have you had from regulators on the tool?
It's funny. Well, I am a regulator. I actually I actually do regulation for Brighton at the moment. So on my own view, it's interesting because I've presented it to Surrey contaminated land officers at a meeting, and it was one of those. And it also there was the Environment Agency, and we had a really good discussion about it, saying, we're not asking for this at the moment. Should we be asking for this at the moment? We also we want sustainability. We all put it in our local plan that we're going to, but how many regulators really follow that up? And we didn't get anywhere with an answer of saying this should be. We'd say because we haven't got. I suppose we're running on guidance and we don't do it at the moment. But it's sort of saying we put it in our reports because we think it's a good thing to do. I haven't had a regulator saying great yet, or anything like that. But I sort of think all these things, it's the way forward, isn't it? Because we just need to say that we are being more sustainable in what we do. Yeah.
Okay, another question. So from Ruth Chippendale, to what extent are the CO2 emissions from landfilled material driven by transport to the landfill, and to what extent by emissions from the landfill site once the material is there, i.e. are the emissions from the landfill site included?
It's a really good question, and this is one where I'm going to, that one I use the published data for landfill. Which is from a government database. I think there's also the RAP database for landfill. They're not the same, which is, it's really hard to do. The government one supposedly says it includes transport to landfill, and therefore I'm not convinced about this, because of course it depends how far you're going. This shows you what's wrong with some of the carbon factors. They're an approximation and they're not, you know, what's the plus or minus on them, and I don't know what the error factors are. In actual fact, it's a whole area that should be looked at more, but at the moment, because something's published, it's helpful. You go, I'm using that data because I can say I have a reference for it, but it's not perfect. So you could do your own. You could do, there are ones for landfill, but I guess I'm deferring to somebody else has done it for me.
Okay, we're doing well on the questions today. There's another one from Jeff Richardson here. Do the reuse calculations take into account the cost and time for treatment to make suitable for reuse?
It includes the transport to the process, and then the basically a carbon factor for that process. Okay, so it's for reprocessing metal, or you can have one for burning the wood, is what it includes. So it doesn't include any time or anything like that. As I say, this all comes down to the same thing. The detail of this isn't perfect, and therefore that's why it's really interesting to clients. I'm very reluctant to give actual carbon numbers. I like to give percentage savings, because it's then you're showing this is better than this by this percent. But actually to give you it's going to be 365 tons of carbon. No, I don't believe it, because I know my data's not good enough.
Mm. Okay, and a question here from Jacqueline Duquette. She says, Emma, thanks, that's very interesting. I'm interested in whether other local authorities have considered requiring this to be undertaken as part of remedial options to tie together, particularly with respect to NPF4 requirements. And Jackie's from Glasgow City Council.
Yeah, as I say, I'm a regulator, and I've never asked anybody to do it. I guess we're not there yet, is the quick answer to that one. But I don't know, I imagine for some regulators on this, what's their view is the only way to turn it around as well, to say, I'm not sure, can you reject something, but, well, you can't reject something, but it's if someone's done it and you can show this is the better option, then it's quite helpful.
I found this coming into play with a lot of my own clients literally within the last year or two. So my clients are all insurance companies, so the remediation that I do is in relation to environmental claims, and quite a lot of my sites are on domestic residential properties. So the insurance companies in the last year or two have asked us to provide like carbon footprint calculations for the remediation works. Although we provide them, I'm not that sure what they're really doing with that information. There's never really been any feedback on that. But dig and dump is traditionally the route for these type of sites, and basically the insurance companies are sort of saying, well, we want to make a commitment towards carbon reduction. They're looking at asking us to do remedial options assessments for every site with the carbon calculations in them, but they have this slightly interesting kind of side to things, which is the social element. So quite a lot of the times we're moving people out of their homes to do the remediation works, and it's not a very big footprint site in terms of doing anything on site. So they're sort of like, well, we want to, and we've probably got the finances to pay more as well, and it's not really a cost thing, but it's like for our customer to say, oh well, we'd like you to be out your house for another 6 months or a year because we'd like to do like a sustainable remediation on your site.
Yeah,
they're not really going to
do it.
That. So yeah, it's interesting how they've wanted it to be part of the process really, but they're struggling with the implementation of it. Cost for them isn't as big of a factor as I think it is for some clients, but they have this sort of social aspect to it, which is the sticking point for them. So
yeah, no, I really want to expand and do other ones and do other remediation techniques. It's whether there is one at the moment which is in Dutch. Now, I think it might have been translated. There is one in Holland, which they've got one which compares one, but they tend to be more, they're slightly backward thinking. It's more, we did this and therefore we use this much carbon, rather than planning going forward, which one's the best. But actually, the dig and dump, the one that's interesting is that I could say as a regulator, I have because I include in that, including the plastic membrane, which is often the no dig layer is put in there. And now that I do the carbon for it, and I know what that includes, I don't like, I'm suddenly going against the idea of no dig membranes as a regulator, because I just think, who knows, if someone's got a property, do they honestly know that that bit of plastic means don't dig through anyway? And are we just sticking plastic everywhere, which has got a carbon impact and it's also got plastic impact? I'm not sure. So it has made me really reassess that one as a regulator. I start looking at them going, I think we only need that where we really need it, not just put it in there because that's what's always been done.
Right, well, that's all of the questions that we had for you, Emma. Well done, there was quite a few. So yeah, I guess all that remains to be said is thanks to everyone for coming, and thank you very much to you, Emma, for your time in presenting to us all today. Very much appreciated.
Thank you very much for the opportunity.
Yes, we will see everyone again on the next SCLF webinar. So yeah, thanks very much, everyone. Hope you enjoy the rest of your day.